This video covers section 13.1, sequences, objective 1, write the first few terms of a sequence. A sequence is just like a function, except we only use the natural numbers to plug in. Instead of using function notation, we now use this notation A sub n. This means plug in n to the function. This means plug in n to the sequence. For example, we used f of n equals 2n plus 3, but instead of f of n, we use a sub n as 2n plus 3. So then the fourth term in the sequence is represented by a sub 4, which means we would evaluate the sequence for n equals 4, or a4 equals 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. The eighth term in the sequence would be found by plugging in 8, or 2 times 8 plus 3. 16 plus 3 equals 19. When we write sequences, we always think of as the first, second, third terms, and so on. We don't normally use the 0th term because we're using natural numbers. So if we wanted to write out the first 5 terms of this sequence, we're going to start off with a sub 1 for the first. And we would get 1 over 1 plus 1, which is 1/2. The second term in the sequence is 2 over 2 plus 1, which is 2 over 3. The third term in the sequence is 3 over 3 plus 1, which is 3/4. The fourth term in the sequence is found by putting 4 in for n. 4 over 4 plus 1 is 4/5. And the fifth term in the sequence is found by putting n equal to 5, which is 5 over 6. Pretty easy to see those terms there, so we say that the first 5 terms are 1/2, 2/3, 3/4, 4/5, and 5/6. Example 2, write out the first 5 terms of this sequence. A sub n is negative 1 to the nth times n squared. Pay attention to this piece of the sequence and what it does. The first term in the sequence is found by setting n equal to 1. That's negative 1 to the first times 1 squared, which turns into negative 1 times 1, which is negative 1. The second term in the sequence, n equal to 2. Now it's negative 1 to the second power times 2 squared. So where we see the negative 1 to the nth is alternating this sign, and then you're squaring the number 4, giving us a sub 2 equals 4. When we do the third term, we have n equals 3, or negative 1 to the third power times 3 squared. And now we're back at the negative, and 3 squared is negative 9. The fourth term, now we're back at putting an even number under the negative, and then 4 squared. That's positive 4 squared, which is 16. Then we're back at the fifth term, an odd exponent on a negative gets us back to negative. or negative 25. Then the next one after that, the 6th would be positive, the 7th would be negative. So we say that the negative 1 to the nth alternates the signs. We had negative 1 first, 4 second, negative 9 third, 16 fourth, and negative 25 fifth. Alternating sequence is what we call it, and then you have the squares. Here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. The first term in the sequence is found by setting n equal to 1. The second term in the sequence is found by setting n equal to 2, which gives us 1. The third term in the sequence is found by setting n equal to 3, which is 3. The fourth term in the sequence is found by setting n equal to 4, and you can start to see the pattern of the sequence. We're adding 2 each step, just like a linear equation, so that the fifth term should just be 2 plus 5 is 7, or setting n equal to 5, we've got 2 times 5 is 10 minus 3 is 7. So the first 5 terms of the sequence are negative 1, 1, 3, 5, and 7. Practice 2. We've got the alternating portion in the negative 1 to the n plus 1. And then we've got 2 to the n this time, so these are going to be powers of 2. First term in the sequence, a sub 1, is negative 1 to the 1 plus 1, 2 to the first. That's negative 1 squared times 2, which is just 2. Notice the difference between the negative 1 to the n plus 1 and the negative 1 to the n. The first term was negative. The first term is now positive. This is going to alternate it and make the next ones positive. So the first term is positive. The second term, 2 plus 1, or n plus 1, and then 2 to the n. Now we're at negative 1 cubed times 4. And now we're back at negative. The a3, negative 1 to the 3 plus 1 is negative 1 to the 4th times 2 cubed is positive 8. A4 is negative 1 to the 4 plus 1, which is 5. 2 to the 4th, which is 16. But we've got negative 1 to the 5th power, which is negative 16. And A5 is negative 1 to the 5 plus 1. Now we're negative 1 to the 6, so we're back to positive. 2 to the 5th is 32. So we say that the negative 1 to the n plus 1, this makes the first term positive and the second term negative. So that makes the even terms 2, 4, 6. That makes the even terms negative. But the negative 1 to the nth power, this made the odd terms negative. The odd terms are the first, third, and fifth. The even terms are the second, fourth, and sixth. Those are going to be negative in practice 2. So that'll be crucial in objective 2 when we find a formula for the nth term of a sequence. And so the terms of this sequence are 2, negative 4, 8, negative 16, and 32 to give us the first 5 terms of that sequence, and again, we'd call that an alternating sequence because of the alternating signs, and those would then be the exponential or the powers of 2, 2 squared, 2 cubed, 2 to the 4th, and 2 to the 5th. And this concludes the video for section 13.1, sequences. Objective 1, write the first few terms of a sequence.